All right, so guys, in the previous video, I was doing question 3. In this video, I'm going to be doing question 5, and this is the trig question. I looked at it, and I don't find it very, challenging, I would say. Okay, but that is just based on, um, me having a look at it, right? So if you're new to my channel, please like, share, subscribe for more awesome content. I don't only post maths videos, I've got more engineering, content coming up. So do subscribe, do comment, do share, and don't be shy to comment if I make a mistake or anything like that. All right, so this is probably the last, time you're seeing trig in high school. Honestly, let me just say, paper 2 doesn't look that bad. I don't know how many of you guys agree with me, but so far, question 3 was so, fair that you could get all your marks. Okay, enough with that. Now look over here. They're not asking you to solve for anything. They just said express each of the following in terms of k. How easy can it be? Right, so we have tan 50, right, degrees is equal to k. We already know that this is that question where you need to have a cast diagram and lots of things happening. All right, since we know that, we also know that we are just giving tan 50 is equal to k. So we know that k is being divisible by 1, dividing k by 1. And what is the tan ratio? Is opposite over adjacent. You know that? Okay, I'm sure you do. Now, we need to express this. But okay, before we can proceed, where is tan positive? As you can see there, we need to have a Cartesian plane. Tan is positive in the first and third quadrant. Right, that is where tan is positive. So, well, we actually have 50 degrees. So we are just here in the first quadrant, 50 degrees over there. Right. So, guys, that means that the opposite is going to be k. The adjacent is going to be 1. That means that our hypotenuse will have to be that's what we're going to calculate real quickly here. Okay, let me just say hypotenuse or radius is equal to square root of opposites, which is k squared, minus adjacent, which is 1 squared. We can just leave 1 there because it doesn't make any difference. Let me just double check that. Nope, it's supposed to be plus. Hey, okay. Some of you guys are going to come at me in the comment section. Okay, okay, so right. I'm too playful, aren't I? Okay, that is going to be our radius. K squared plus 1. Okay, k squared plus 1. That is what we have over there. Let us go and calculate. Well, we're not doing any calculations. We are just trying to find out what are the other values over there, which is weird because over there they're saying, over here they're saying cos 40. So this one is not going to be straightforward because you clearly don't see 40 over there. So what do we need to do? We need to use our core functions. I guess that is what happens when you're doing this tutoring thing, It kind of messes you up a bit, but not completely. So we have tan 90. All right. Sorry about that, guys. Sorry about that. It's not supposed to be tan. What is cos 40 equal to? Cos 40 is equal to cos 90 minus 50, right? We all agree. This will be cos 40, right? Now, we are going to ignore that other part and use a core function here, right? What is cos 90 minus an angle? It is going to be, remember it's a core function, it's going to be sine 50, right? It will be sine 50. Now, let us go and look over there. Here, we need to get this now. Sorry. Now we need to answer the question. What is the ratio of sine 50? Sine 50 would be opposite over hypotenuse, which would be opposite over square root of k squared plus 1. That is going to be your answer for this part, guys, is equal to k over square root of k squared plus 1. Okay, that is what we have over there. All right, now let us just move on. First question being completed. Allow me to just erase this because we know that it's in the first quadrant now. Now let's look at this. For 5 marks, we have 2 sine 25 theta times cos 25 degrees, or I don't know why I say theta there, minus 2 plus sine squared 25 degrees. Okay, what are we going to do? It's very easy. We can look at the numerator and you can see that that is a double angle there. Now, it's a double angle for sine. So you would have already torn up your formula sheet and are just ready to answer these questions here, so that you don't do page flipping and stuff. So what is the double angle of sine? When you have this going on, 2 sine, you know that it's going to be a double angle of sine basically. So the numerator itself is going to be sine, right? Sine 2 times 25, which is literally sine 50, right? That is the numerator. We're going to divide this by, now look at the denominator. Okay, guys, I forgot to put 4 here. When we look at the denominator, let me now start writing it in a different color because this one is not simplified as yet. I have 2 minus 2 and I have plus 4 sine squared 25, right? When I look at my double angles, okay, cos, okay, let me write it here at the bottom, right? At the double angles, cos 2, let's just say cos 2 theta is equal to cos squared theta minus sine squared theta, right? And then the other one, cos 2 theta is equal to 2 cos squared theta minus 1, and then cos 2 theta is equal to 1, is equal to 1 minus 2 sine squared theta. This is the one we are going to use, guys. This is the one that we're going to use, the bottom one. So we just need to make the denominator look something similar to that, which won't be a problem because we just have to factor out minus 2, right? If we take minus 2 out, it'll be 1 minus 2, right, sine squared 25, right? The reason why I did this is because when I multiply this, it's going to be minus 2. When I multiply that, it will be positive 4. So that is the denominator. Now let's just simplify that. The numerator is going to look like this. It's going to be sine 50 degrees all over minus 2. But now, what is 1 minus sine squared an angle equal to? It is equal to cos 2 theta, right? So we are going to multiply this angle by 2. Basically, we're just going to say what? We are going to say cos 2 times 25, which is going to be 50, right? Which is going to be 50, right? That looks like a 3. 50 degrees. We close that. And now let's just simplify this, right? Which won't be difficult. Let's look at it. Right, the numerator is going to be sine 50 degrees all over minus 2 cos 50 degrees. Guys, don't even go and waste your time by substituting at this stage. With a sharp eye, you can see that there is a 10 ratio there, right? So, and there we have what? We have an invisible one, basically. So you can just separate them like this. So it'll be minus 1 over 2 times sine 50 over cos 50, which is literally this, minus 1 over 2 tan what? Tan 50 degrees. And what is your tan equal to? Your tan was equal to k. Tan 50 degrees was equal to k. So what are we going to say? We are going to say, since our tan 50 degrees is equal to k, that means that this entire expression is going to be equal to minus 1 over 2, because we have tan here, tan 50 degrees, which is k. We're just going to say, instead of writing that, we are just going to say minus 1 over 2k. And that is going to be your answer for that portion. All right. Again, that doesn't look difficult. It looks like they're just giving marks at this point. This is going to be equal to minus 1 over 2, 1 over 2k. Okay. Minus 1, okay, over 2k. Now, let's move on to the following question. I think this might be a bit interesting. We just have tan there. Where do we even start from? We will find out just now. Okay, this takes a long time. I don't know. Okay, I'm using the thing. Okay, that's better. Okay, here we just have sine 10 degrees. Okay, what is sine 10 degrees potential probably equal to? Sine 10 degrees. Well, if we look at it, it could be equal to sine, right? What can we say? 90. Okay, I didn't really think about this one here. Okay, my apologies for that. Sine 40. Okay, don't worry. Interesting. Sine 40 is definitely equal to sine 50. Okay, is equal to sine 50, and then what? Sine 50 minus 40. Right, sine 50 minus 40. Or what we could do, right? What we could do, we can say sine, right? We have we could say sine 90 minus 80. Okay, sine that minus 80, which is going to give us cos 80 degrees, right? And cos 80 degrees is the same as saying cos 40 plus 40. All right, just watch where I'm going with this. Is cos 40 plus 40. And if we open it, like if we remove these brackets, we're going to have cos 40 and we're going to have sine 40. Okay, that's the bad thing with erasing the board. Okay, that's a disadvantage of erasing the board. But don't worry, let me just go back to the top here. All right, so let's just work with the first example that I've put up, right, which is this one here. What do we do? It's going to be sine 50 times cos 40 minus sine 40 times cos 50. All right, let me just make some space. Okay, let's write that properly now. Cos 50. I hope everyone is following me so far. Now, what is sine 50 when you look at this? Right, now I have to bring that up. Oh, look at that. Sine 40, but we don't have sine 40 anyway. Okay, we just have cos 40, but no problem. Okay, let's see this. This is going to give us, okay, now I have to plot this once again. What did we have here? We had 1 and we had k. We had square root of 1k. I mean, k squared plus 1. That is what we had. So the ratio of sine 40 is going to be equal to, I mean, this is 50. Sorry, guys. That is 50. So sine 50 will be equal to opposite, all right, which is k all over square root of k squared plus 1. All right, times cos 40, which also happens to have over here already, which is k over square root of k squared plus 1. Okay, and we are subtracting this with sine 40, which we don't have. But we have cos 50, isn't it? Okay, let me just write cos 50 for now. Cos 50 is going to be adjacent over hypotenuse. It's going to be 1 over the hypotenuse, which is square root of k squared plus 1. Okay, now we are multiplying this with cos 40. No, sorry. This is cos 40. We have sine 40 here. Okay, what did we do with sine 40? Did we even see it? Anyway, if we have cos 40 here, what is sine 40 going to be equal to? Okay, that's another one. It's a different question. So if we have sine 40, right, guys, sine 40 will be equal to sine 90 minus 50. Right, so it's not a difficult question, which is going to be equal to, again, cos 50 degrees. And what is cos 50 degrees, guys? Cos 50 degrees is here. All right, I know. It seems as if what I'm doing is confusing, but just try to follow through. Replay the video and you will get what happened. right? You will get what happened. It's an interesting question. I like it. I like this one. So what is cos 50? Cos 50, we already had it over here because we were trying to figure out what is sine 40, right? We knew what was cos 50 based on the ratio, right? We knew what was cos 50, and we converted this using the core function, and we now know that it's going to be the same thing literally. Sine 40 is the same as cos 50, right? So we're just going to multiply this with cos 50, which is also 1 over square root of, k squared plus 1. All right, interesting, interesting. Now let's just remove this. And what do we get now, guys? We are going to have k squared over k squared plus 1, right? Minus 1 over k squared plus 1. Okay, so how would you subtract this? Don't even stress. It's just going to be k squared minus 1 over k squared plus 1. I don't know if you try to crack your head over here, but these are basic fractions. So, boys and girls, our answer was just going to look, ooh, we can't leave it like that, can we? I think we can have some fun with it, can we? We can only simplify the numerator. The denominator we can't, so it's fine. We leave our answer as that. Okay, I don't understand why this question was 4 marks. It was supposed to be 5, and the top one was supposed to be 4. So k squared minus 1 over k squared plus 1. Okay. I can see this paper was fun. This paper was fun. So moving on. Okay. Let me just erase this real fast. It is taking a bit longer than I expected to complete this question. So let's go. We're done with that. Now let's just simplify this one here. All right. I don't know why I erased the answer there. Okay. Sorry about that. Okay. So let's simplify this expression. I don't know why I did this. I marked it, but right. Simplifying expressions, guys, is very easy. I'm not going. Okay. Let me just rewrite that. Sine 540 degrees plus x times cos 90 degrees plus x all over sine minus x. Guys, if you have a bigger number in there, you just say 540 minus 360, and you're going to get 180. So in the numerator, we have sine 180 plus x times, right? This, we're not going to do anything with it at the moment, so we're just going to say cos. So we do this to avoid problems, right? 90 plus x. Now let's go in the denominator there. We're just going to say sine 360 minus x. If there's a negative angle there, you add 360. Now let's start reducing. This here, okay, hold on. We need something important. So yesterday's I was going this. Okay, never mind. Yesterday is in the past. So all students take care. Okay. For you to get high marks, never mind. I don't want to be, to be restricted by YouTube by using my broken humor to go through this, eh? So what we're just going to do is just focus on the question. All right, let's use a reduction, right? And we have here sine is going to be negative in the third quadrant, so it's going to be minus sine x times cos. Cos x is going to be negative because, cos is always only positive in that. That is, sorry, 90 plus x is only positive when it's sine. So this is going to be minus sine x. We will divide this by sine 360 minus x, which is going to be cos x. All right. Okay, our equal to sine equal to sine. So in the numerator, we have sine squared x. In the denominator, we are just going to have cos x. And guys, this is the same as saying sine x over cos x times another sine, because we have sine squared, sine x over there over 1. So this is, guys, the same as saying tan x times sine x. Guys, you would have gotten yourself an easy 4 marks just by doing that. Okay, an easy 4 marks by doing that. I still can't believe that this paper was written today. Tan x times sine x. That is the answer over there. Like, really? All right, moving on. The following question, we need to, what are they saying here? They need hence determine the values of x between the intervals of 0 and 360 for which this will be real. Okay, guys, for this entire expression to be real, well, the denominator has to be equal to something, right? The denominator doesn't have, if the denominator is 0, then that entire expression is not going to be true. Okay, so just give me, oh no, watch this, guys. We already simplified the numerator, so they're just saying hence, so we need to focus on the denominator. So for the answers of this to be real, it means that our denominator has to be greater than 0, right? Let's go and figure that out. So we have sine minus x is equal to 0, right? So basically we're just solving for x. Okay, sine 360 minus x is equal to 0, therefore this is going to be sine x is equal to 0. Let's find the angle. X is equal to sine, right? And we put 0 in there. Shift sine 0. Whoa, we are getting our answer as 0. Isn't that concerning? Is that not concerning? Okay, x is going to be equal to 0. Okay, so let's just substitute 0 and see what happens to the entire equation. That is kind of weird, but sine 540 degrees, 540 degrees plus 0, close that, times, okay, don't even write sine, just take the tan since it's the same as that. So you're going to say tan 0, close that, 0 degrees, right? Tan 0 degrees, close the brackets, and then times sine 0 degrees, close the brackets, all over sine, okay, all over sine 0 degrees, right? What do we get? Undefined, right? So in your calculator, if you put sine 0 degrees, okay, just a moment, your answer is going to be 0. So your x values have to be greater than what? Your x values have to be greater than 0 because the reference angle that you're getting, they're saying that x is equal to 0, right? That is your reference angle, but in which quadrant are you focusing on? You are going to be focusing in the first quadrant, and all students in this quadrant here. So now x is going to be equal to, in the first quadrant, well, it has to be, it can't be 0 now, can it be? Okay, you can't say 0 there. Actually, you can, you'll just say 0 plus 360k, right? And then you say k is an element of real integers. And then in the second quadrant, x is going to be equal to 180 minus theta, which is 0. So let me just say 180 plus 360k. But then again, that means that our answer is 0 degrees and 180, right? So we can't put 0 because 0 is not going to give us the answer that we need. So it's going to be between 180. Now, how do we find the other values? Well, it's very easy. You need to substitute either 1 minus 1 into the value of k to find out. Okay, so in this place here, if we put 1, it means that we're going to have x is equal to 360. Okay, that can work because that is part of the ratio. So I mean part of the restriction. So we can also have 360, right? And also if we put minus 1 over here, that is going to be 180, right, minus 360, and we don't need that because we're only starting from 0. Okay, so these are actually going to be our answers, because if we put 2 or minus 2, is going to be way off. Now if you say sine 180 degrees, okay, well, funny enough, everything is just giving me a 0 here. I don't understand why, but if I put 360, okay, just give me a moment. If I put 360, also going to give me 0. So what were they asking this question? Okay, so if you have any idea, it's a very easy question though. I know it's a bit tricky, but if you have any idea of what to do in that last question, just comment and let's see if we share the same, the same thoughts on how to do that last question. All in all, this question was an easy question, 17 marks. Anybody could have bagged that. It was just this weird question in the bottom, which, if you think about it, okay, let me get back to that question. Right, okay, this is what we have. Remember, the numerator of this is equal to tan x times sine x. Okay, remember, the denominator, it is sine minus x, so we'll just say 360 minus x. Okay, looks like I refuse to move on without getting it. This is going to be sine x. Guys, that means that our denominator is sine x. Okay, now let's just simplify what we have in there. Okay, I just refused to proceed without, so that means we get that. Now we have square roots of tan x, right? We have square roots of tan x, and we are supposed to find out the values for which this will be real. Well, how do we do that? Whatever is under the square root sign, it has to be greater than 0. So okay, it's not so bad actually. I don't know why I was just moving in a weird circle there. um if you're watching this, you probably have thought what I'm doing now. All right, so it's going to be tan x. Tan x has to be greater than 0, but I'll just equate it to 0. Therefore, x is going to be equal to shift tan 0. Our answer is going to be 0. Okay, tan is positive in which quadrant? Tan is positive in the first quadrant and in the third quadrant, right? And okay, so hey guys, don't come at me. We just have to say x, or you can leave it as just say tan x has to be greater than 0. Okay, just leave it like that. All right, so guys, I'm not going to do question 6 in this video because this one is already long. Part 6 is coming up shortly. Cheers.